All right, welcome back, everybody. Today we're covering trigonometric functions. So to start this off, let's say I've got like a little x and y graph here. And one way of having a coordinate like a comma b or x comma y, we can just have the ordered pair there. Another way of describing this is talking about like how far away that thing is from the center and the angle that comprises it. So like another way of looking at this, we'll see this more later, is r theta. This is not in 5.2, but it's more like to introduce the idea of where this stuff comes up. Depending on where the dot is around it, this could be anywhere on an entire circle going around it. So that's why we use r, because it could make a circle. Any point on this circle is gonna have the same radius, it just has a different angle. So r is like the length here for a radius of the circle. That's not what 5.2 is on. But these are called Cartesian or rectangular coordinates. And as we'll see later on, I think it's in the last chapter we do, these are called polar coordinates, much later in the course. We convert to them, all that good stuff. Where we use them the most. But having the connection between this stuff right away is useful. Because for any point on there, we can make a triangle. So now I have it's called a right triangle because that's a perfect 90-degree angle. And we use a box to indicate a perfect 90-degree angle. While I'm sure it will come up some point in this chapter coming up shortly. Triangles add up to 180. The angles in a triangle. Angles in triangles add up to 180. 180 degrees. We'll need that later. Let me redraw that triangle right here without the circle line. That X and Y axis on there just to show it. The reason why that point is X, or that point being XY, we'll call it, means that we've gone this distance X and this distance Y. So the triangle really has X for one side, Y for another side, and this angle is called theta. And this is R. We're going to use that R right here. So you might have heard of SOH. There's relationships between the angles, between an angle and sides of a triangle. The ones for a right triangle, the right triangle relationships are the following. The first one is called sine. It's abbreviated sin. We still pronounce it sine. Yeah. We chopped off all of one letter to shorten it, because we're fucking clever people as mathematicians are. So we'll say sine of theta. Sine of theta is gonna equal the opposite side over the hypotenuse. The hypotenuse is the longest side of a right triangle. And for us, that's the arc. Cosine is abbreviated COS, like College of the Scotus. I was a little lazy there. That should say opposite side. And I just wrote OPP. I want to do that on this one. Cosine is adjacent side over hypotenuse. And adjacent means next to. If you're unfamiliar with this word, it means next to. Or alongside. Kind of thing. And finally, of the top main three, we have tangent. And it's abbreviated tan theta. And it is opposite over adjacent. Pause, let that shit go. I'm gonna put some letters in some boxes, or. This S, this O, and this H is used to go SOH. Sine opposite hypotenuse, SOH. We do the first letters with the other two as well, cosine adjacent hypotenuse. We call it CAH. This is a memory mnemonic to remember this stuff. And then tangent has T, O, and A. SOH. Get a bunch of pins, so moving, for everyone. So let's look at that triangle again. And figure out what these things are. Sine of theta is opposite over hypotenuse. This side here is the hypotenuse. This side is opposite of that angle. And there are two sides that are next to the angle. This side and this side are both next to the angle. But one of those is already the hypotenuse, which makes this side down here the adjacent. So sine of theta being opposite over hypotenuse, the opposite side is y, and the hypotenuse is r. And we'll discuss how to get r when you set x and y. But let's play around with this first a little bit. Cosine theta is adjacent over hypotenuse. The adjacent side is x over r. Finally, we have tangent theta, which is opposite over adjacent. And the opposite side is y, and the adjacent side is x. For these two things to work, a couple things have to be true. On both of these, r cannot equal 0. We can't have the denominator equal to 0. Now, thankfully, that's never an issue. If r equals 0, we don't have a triangle and we're not even talking about this shit. So r is never going to equal 0. The one that could equal 0, which could be a problem, is this one. X cannot equal 0 because it's in the denominator. You remember from pre-algebra and algebra, we can't have 0 in the denominator. We have 3 more basic trig functions. These are the lesser used ones, but they are important. They do come up. We could have cosecant. Cosecant is abbreviated CSC. And it is hypotenuse over opposite. So r over y. And you'll notice, you might notice, this is sine theta flipped over. Flipped upside down. We'll come back to that. What that's called later on. The next one we have is secant. It's abbreviated SEC. And it is hypotenuse over adjacent. So r over x. And this is cosine flipped. And finally, we have cotangent. It's abbreviated COT. And it is adjacent over opposite. Which is X over Y. And this is tangent theta.
Specific way to not remember these.
Yeah. I will show you. These are the 6 basic trig functions. 6 trig functions. I guess saying basic is a little off. These are the 6 trig functions. There are no others. Looking at the triangle, does anyone know the relationship between X, Y, and R? Yeah, there's something called the Pythagorean formula. Which is a squared plus b squared equals c squared. And c is the hypotenuse. So how this applies to the triangle is x squared plus y squared equals r squared. Which in when you take an algebra is the equation of a circle. Because any value, they generate the circle like we showed on the previous page. Which means if I take the square root of both sides, r is the square root of x squared plus y squared. Now, normally when you take the square root, you have a plus and a minus. When you take the square root. But I'm going to say, ignore the minus for this. Why would I say that's okay? What? Radius has got to be a positive number. It's representing a length. You can't have a negative length, like you didn't walk or drive negative miles to school today. That doesn't make sense. So lengths or distances are positive, so we can just treat it as a positive. R equals square root of x squared plus y squared. I know a lot of you are used to this as the square root. I tend to do this little drop off after thing like the eve on a house. It kind of tells you where the square root ends. So if you have shit after it, you don't accidentally think it's under the square root. It's pretty handy. Got this written down, we'll do some examples of these. Look at some triangles and we'll identify the 6 trig values. The terminal side of an angle. In standard position. Passes through the point 12.5. Find the value of the 6 trig functions. Now, the technical name is trigonometric, but that's a mouthful to say repeatedly. As often as we're gonna say it, so I will abbreviate trigonometry or trigonometric to trig. As a lot of people do. So standard position means it's going through the origin, the line starts at the origin. And when it says the terminal side. It has rotated an angle theta like that. And is going that direction. And it says it passes through some point 12. And some height 5. Giving us 12.5 here. Now we need to pull some information from this. It means it's where the angle stops, like standard position means it starts here. And it rotates a certain amount, like this is the initial side. And where the side stops rotating to, like if you had something like on an axis. And it's like that and it rotates, terminal means where it stops, terminal is end. So where it stops. That's what's going on. I'm gonna like redraw this over here like this. Cause we can make a triangle out of it. If we do that, this distance here is how far it went, that's gotta be the 12. And the up and down is the y value, that's gotta be 5. To find these 6 trig values, we need the other side though. We need R. This is actually a well-known triangle in architecture and engineering. If you do the square root of 12 squared plus 5 squared. You get 144 plus 25. Which is the square root of 169, which is 13. So this is called a 5, 12, 13 triangle. With that being the triangle, let's find our 6 trig functions. Here, writing one way, then she rotated it to get more shit in on the same page. She's got shit going all different directions. If it works for you, it works for you,
Gotta make it interesting.
right? Rotate your notebook while you study. Pull that little cheat sheet up real quick. Sine theta is the opposite side over the hypotenuse or the long side. What is that on our triangle right here? 5. That's the opposite side. What's the hypotenuse? 13. Cosine is adjacent over hypotenuse. The adjacent side is the side next to it, is the 12. And the hypotenuse is 13. That's another way to write a fraction. Give you a little diagonal. That usually helps just save space. And tangent theta is opposite over adjacent, which should be 5 over 12. Now, to do the other 3, I don't know that it's helpful to try to remember this R over Y, R over X, X over Y. I think it's easier just to remember to flip those some bitches. Flip. So we'll have 13 over 5 here. 13 over 12 here. And 12 over 5 here. Now, doing the flip method, the only real thing you gotta worry about remembering is what one goes with what, right? So, and this is how I remember it. Tangent and cotangent go together. The names alone tell you they go together. They both got tangent in it, right? Now, where they come off with secant, cosecant, I don't know, it must mean something in fucking Latin or Greek or some shit like that. The way I remember which one goes with which is notice the S and the C. They go to the opposite letters on the other one, C and S. Now, I really wish they went to the same fucking letter. I really wish sine paired with secant and cosine paired with cosecant, but that it doesn't. You just kind of gotta remember it goes with the other starting letter. So if you remember these 3, then you can remember this one, like cotangent's got a flip. And of the 2 remaining, cosecant and secant, just pick the one of the opposite starting letter. That's not too hard to remember. After you get it done and do it a few times, it's habit. Remembering the names of them or what they are abbreviations of, once you've seen it enough, it gets familiar. Sine, cosine, tangent, secant, and cotangent all start, they're all the first three letters of the words. The only one that's fucking off is cosecant. Cosecant, the first three letters of its word are COS, and we already have that for cosine. So they picked three other letters. So cosecant is the only one that doesn't have, start with the first three letters of what it is. Any questions on that? All right, let's throw another one at you. Save yourself some writing, let's just say same shit. Passes through. 4,3. Unless you wanna write down this entire fucking long ass sentence again.
Right.
If that's your cup of tea, go for it. Triangle looks like this. The X value is 4 and the Y value is 3. If I do R. R is the square root of those two sides squared, 4 squared plus 3 squared. Which is square root of 16 plus 9. Square root of 25, which is 5. R equals 5. 3, 4, 5 triangle is another very common triangle. One of the Pythagorean triangles. There's a lot of them that are made in perfect integer values that square. Line up sine with cosecant because it starts with the other letter. And I'll line up secant with cosine because it starts with the other letter. And we line up tangent and cotangent. Go by our mnemonic, so for TOA. It tells us the letters in which order to go in. Sine is opposite over hypotenuse, which is 3/5. Cosine is adjacent over hypotenuse, which is 4/5. Tangent is opposite over adjacent, which is 3/4. Then we'll flip 5/3, 5/4, 4/5. Let me give you guys one to do, and then we'll look at it together after I give you a couple minutes to give a go at it. Same shit. Passes through 8, 6. Feel free to talk to your neighbor if it will help. I strongly encourage studying together. The sooner you get in the habit of doing that, the easier your entire fucking degree is gonna get. Or whatever you're here for. So. If I draw this. I have 8 here and I have 6 here. What'd you guys get for R? R is 10. So if I go through and set up my 6 trig functions. What is sine theta?
6 over 2.
6/10. Cosine theta,
8/10.
8/10. Tangent,
6/8.
6/8. Having so many voices, this is confusing the shit out of me. Interaction? What? What?
You simplified or no?
We will,
Oh.
we're getting there. No one did yet, so I didn't go with it. If we flip this, we got 10/6, 10/8, and 8/6. Notice these are even numbers though. 6/10 is the same thing as 2 times 3 over 2 times 5. When you've got numbers multiplying both on top and bottom, we can cancel them out, leaving behind a 1, and this reduces to 3/5. So all of these I can like divide top and bottom by 2 because they're all even numbers. And it doesn't simplify any more than that. Notice anything about this problem and the previous problem? They're the same. The triangles are different. The 3, 4, 5 triangle and the 6, 8, 10 triangle. Are different sized. But the 6 trig functions are the same. Which kind of tells us something important. The angles are the same. It's just double the size. If you look at it on one graph. Let's see, we had 4, 3. This would be 8, 6, 1, 2, 3, 4, 5, 6. So 4, 3 was right here. 8. 6 is right here. The points are on the same line, they're just making different triangles. If my grid line was better lined up. So. The 6 trig functions alone. If that was the only piece of information we have. Doesn't tell us everything about the triangle. It's all different sizes of triangles. The important part is that they all share that same angle. See that angle right there? We have a word for these triangles. These triangles are called similar triangles. And what that means is their angles are everything about the triangles are proportional. They all have the same proportions. With that theta. Proportion is like a fraction. So they can all be reduced to the same fraction. Let's take a 10-minute break and then we'll come back and dig more deeper into some of this stuff. We'll talk about where X is 0, Y is 0, and what's happening there. Look at some other stuff. Pause the recording. All right, we got this question here. We're gonna make the six trig functions made by 1 and 3x minus 2y equals 0. So what we can go about this, let's write this in a form that we're familiar with. If we solve for y, we can subtract 3x from both sides. And we get negative 2y equals negative 3x. And if I divide both sides by negative 2, I get y equals negative 3 over negative 2x, which is the same thing as positive 3 over positive 2x. Now, if you remember your algebra, this part here is m, and it gives us our slope, which is rise over run. Which means I would have a rise of 3 and a run of 2. It's a point right there. Or I could go the other direction using the negative values, go down 3 and go left 2 and put a point over here. So this is that line. Says x is less than or equal to 0, says we're just looking at this portion. Which means I can make a triangle like that. And x here is negative 2 and y here is negative 3. And we're going to use the angle it makes with the closest line to be our angle there. That's going to be our theta right there. So if I want to find R has got to be that distance right there. That's R. And R has got to be square root of negative 2 squared plus negative 3 squared. Which is square root of 4 plus 9. Or the square root of 13. Don't turn it into a decimal. The reason why, and I hope I will try to beat this into your head. As soon as you put this into a calculator for most square roots and stuff like that, and start doing a decimal, you have to round. And if you round, it is no longer 100% correct. Not a big deal, it's called an approximation. But if you're gonna be an engineer and do some shit like that where you're wanting to build shit, inaccuracies can kill people. So like avoid rounding until the very end, final, whatever you're doing in your engineering or related field. round at the end if you need an exact, needed a closest decimal. Otherwise, leave it as the fraction with radicals, because you can always get a new decimal out of the square root of 13 later on if you need it. But working backwards and trying to figure out what square root it was the other direction, it's fucking gone as soon as you take the square, like use a decimal. So we're gonna use that for R. We'll do our 6 trig functions. Sines one starts with the other letter. So it's cotangents or cosecants, cosines, fuck. Start running through the names. My mom used to do that shit when she was mad at me and my brother. She'd go over everybody's name in the fucking family, including the dogs. Before, and she's madder than shit. My brother's name is Ryan. Ryan, Dusty, Molly, David. And I think she finally figured out like who the hell she's mad at. Done great.
The dog has my name, so imagine her not.
Right? Molly was a great dog. Dog, I love dogs. Dogs are my cup of tea. Alright, so like sine of theta. What do we got here? Opposite is -3 over hypotenuse is square root of 13. Now, you should not leave radicals in the denominator. So a quick little reminder from algebra of how to get a radical out of the denominator is multiply the top and bottom by the same radical. This makes that -3 root 13 over 13. Cosine is adjacent, which is the -2 over square root of 13. It ends up doing the same thing. -2 root 13 over 13. And tangent theta is opposite, which is -3 over adjacent, which is -2. And the two negatives will cancel out and we'll come up with a positive j. Cosecant, we'll flip them. I recommend flipping the first one because it's already done. You have a radical on top now. What if I had said x was greater than or equal to 0? I'm kind of pulling stuff from 5.3. I looked ahead at 5.3. Some of the stuff I've already said is in 5.3. So I may not finish 5.2 today, but 5.3 is going to be fucking shorter when we do it on Thursday. If we had done x is greater than 0, we're now looking at this section. And that triangle is gonna look like this. 2, 3, there's my theta. And if I square -2 or -3, 2 and 3, we're gonna see we get the same square root of 13 either way. So if I do that, I see sine theta is opposite over hypotenuse, which is 3/√13, which was 3√13/13. Cosine theta is 2/√13. And we will rationalize that by multiplying top and bottom by that radical. Tangent theta is straightforward, 3/2. If I go through with the cosecant, secant, and tangent or cotangent, I'm just flipping those three. We get √13/3, √13/2, and 2/3. And draw that other triangle on here, see them at the same time.
Real quick, can you explain, how the percent flow for either 1%? How do you eliminate the 13 on the bottom? You know, for CSC, it's
I actually took this part and flipped that one. Yeah,
okay.
now if you try to do it the other way, if I had done 13/-3√13. You can still get there, you multiply top and bottom by √13. This top becomes 13√13. And the bottom is -3 times 13. And the 13s cancel. So you still get the same result using that one, but like it's easier just to flip the other one. Notice anything between these two triangles? Not quite opposite, some of them are opposite, some of them are opposite signs, but not all of them. Like tangent and cotangent haven't changed signs.
The radius is the same.
The radius is the same on both, the values look pretty close too, don't they?
Just inverses.
They're just opposite sign, like sine and cosine are opposite signs. Secant and cosecant are opposite signs. But tangent and cotangent are the same sign. This is because these two angles, the red angle here, red theta and blue theta, these are called reference angles. This is from 5.3. So they won't mention reference angles in 5.2 homework, but these are related. And reference angles are made by making an angle with the closest x-axis. So when I was down here, the closest was going straight up the x-axis there. When I was over here, the closest x-axis was coming straight down to this one. It actually happens in any of the quadrants, if we're in the upper left or in the lower right. And this reference angle idea. All of the sines, cosines, tangents, all the 6 trig functions are gonna have the same numerical values. Just the signs will be different. So. With these, maybe I'll throw in X and Y right there to make it clear that. What those are. With the reference angles. I don't think that shows up well. All 6 trig functions. Will have the same value. Other than sines. Positive or negative. So let's figure out what those signs are. Let's just make a table of them and a way to memorize them. So if I had some point over here, X, Y, both of them are positive. Remember, R is always positive. In quadrant one, this upper left quadrant here. One way of saying R is always positive is R is greater than 0. If R equals 0, we don't have a triangle anymore. So up here in quadrant one. X and Y are positive also, so all of our 6 trig functions had X, Y, and R, and if all of them are positive. All 6 trig functions are positive here. U1. From over here in Q2. My Y is still positive, my Y is greater than 0, it's above the x-axis. But X is actually negative. So that means the ones with X in it are gonna have negative values, right? This says cosine and secant will be negative. So tangent and cotangent. Which means the only positive ones in Q2. Positive ones are sine. And cosecant. This is the easiest way to go. If you ever get confused, stop and go, what is the Y? Is the Y value positive or negative? Is the X value positive or negative? And you can figure out what the sign should be. I'm gonna try to give you a way to memorize it a little bit easier than that. Down here, they're both negative. In Q3, both are negative. Which means sine and cosine are negative. And that means they're flipped over once, cosecant and secant are negative. Which means the only positive ones. In Q3 are tangent and its partner cotangent. Positive. And they're positive because the negatives of the Y and the X cancel out. Like we saw in this problem right here, the -3 and the -2, tangent ended up being positive. So we saw that in like the tangent up there. We saw that in the tangent and cotangent up there. In quadrant 4, down here. X is positive, we're to the right of the Y-axis, Y is negative. which means anything with y in it is negative. Sine, cosecant, tangent, cotangent are negative. In fact, the only positive ones in Q4 are cosine and its flipped over partner secant. Give me a chance to write that down before we go over an easy way to remember it. What's the easy way to remember this? Going around counterclockwise in a circle like that, ASTCC. Now, I have seen some dumb ones. Well, I think it's dumb. The way I've heard it said is all students take calculus. Now, this is not true. Not all students take calculus. That's the one that if you're the pure of heart, use that one. That's not always true, and I don't like it, like the whole PEMDAS for order of operations, if you heard, please excuse my dear Aunt Sally. I don't have an Aunt Sally, and I don't know if she would be dear if she was my Aunt Sally. I do have a dumbass sibling though. So please excuse my dumbass sibling works, sibling is a brother or sister. Now, the one I remember for this is all strippers take cash. This is a true story. You will never see a stripper turn down cash. This is not a gender related comment. Please don't think this is a gender related comment. There are male and female strippers. And non-binary strippers. I'm sure. I haven't seen any yet, but I don't visit strip clubs anymore. All right, so what does the acronym represent? It really tells us what is posited in these quadrants. A, all of them. S, sign and it's flipped, because. And it's called the reciprocal. We'll talk about that in a second. T is the tangent one, tangent and it's reciprocal. And C is cosine and it's reciprocal. Those are the positive ones. All strippers take. If you don't like all strippers take cash, you can go with all students take calculus. But like I said, it's not true. I know a lot of people that do. Most college students don't take calculus. STEM students do. All right, so what is this reciprocal thing we're talking about? Let's take a look at that. Does anyone need that page longer? Anyone say yes? If you do, say something. About that. So the reciprocal. Identities, they're also called the quotient identities. When I said cosecant is just sine flip, this is exactly what I meant. Cosecant theta is 1 over sine theta. Because if you think about sine theta is the same thing as sine theta over 1. Anything divided by 1 is just itself. So if I flip it, I really have 1 over sine theta. Secant theta is 1 over cosine theta. And cotangent theta is 1 over tangent theta. The same is true if I flip both sides here. I can easily just as well say sine theta is 1 over cosecant theta. Cosine theta is 1 over secant theta. And tangent theta is 1 over cotangent theta. Just by flipping that equation over. So reciprocal means flip it. Five over 7 turns into 7 over 5. Just take the fraction and flip it upside down. Like a pancake when you're making pancakes. Has anyone in here never participated in making pancakes or watched them being made? You never know. I teach stats and I've got oftentimes half the class nowadays has never seen a deck of cards, playing cards in real life. Most of the ones that have seen them, like solitaire on the computer. They've never actually had a deck of cards in their hands. And you're missing out on some good shit. That's how playing poker with your friends and good stuff there. Quotient is the outcome of division. When you divide something, you get a quotient. That's why they call them quotient identities. You're dividing. That's not, you like don't need to memorize it, but that's where it comes from. Now, we've taken a look at all the ones, like all the angles. This word applies to most of the angles. The only thing this kind of stuff doesn't apply to, not entirely, is what about the quadrantal angles? Oh, I said it again. I said I was never going to say it again, and I said it again. What about the quadrantal angles or the angles on the axes? The angle that ends up on the X or Y axis. We're still going to do all the same shit. Let's take a look at an example. Let's say we have an angle of 90 degrees. Angle of 90 degrees, remember we always start at the x-axis. 90 degrees is there, it puts us on this y-axis. Now, remember any triangle, it doesn't matter which size of the triangle, we can always simplify it. I'm gonna say we're going out a distance 3 here. And you'll see that it ends up resulting in the same thing as a 1. So that point right there is 0, 3. And this is where the not thinking about opposite and adjacent comes in, because I don't see it. Like the triangle, the angle looks funny, let's think about the x and the r. So sine theta, cosine theta, tangent theta. This was y over r, x over r, and y over x. What is r? It is the hypotenuse, but on a normal triangle, here we're gonna just use it like the radius, it's the distance away from the center. It still is x squared and y squared. 0 squared plus 3 squared, and then we take the square root. R is 3. So if I do sine theta, I get 3, which was y over 3. Sine theta is just 1. That's what I was saying, it doesn't matter if we use 3, what number we use, it's gonna boil down to a 1. Cosine theta is 0 over 3, which is 0. And tangent theta is 3 over 0. Uh-oh, we fucking divided by 0. So when the result would be dividing by 0, we say undefined. Often abbreviated just undef. Like that. If I flip these. Three over 3 is the same as 1 over 1, we still get 1. Secant theta would be 3 over 0. So this bad boy is undefined now. And cotangent theta is flipping this, it's x over y, 0 over 3 is 0. So when your point ends up on one of the axes, you're gonna end up with a couple of them that are undefined. We could make a giant table of which ones are undefined depending on which axes you're on, positive or negative. That is harder to fucking remember than just like doing these 6 trig functions and going, which ones end up with a 0 on bottom. It's not worth memorizing a table. Let's take another shot at that all strippers take cash thing. Let's try to figure out which ones are positive, which ones are negative, without having any points. Determine the sign of the 6 trig functions. Let's say the A, we're gonna do an angle of 54 degrees. B will do 245 degrees. Let's say C is negative 80 degrees. And D, we'll say 120. So it might help to draw yourself a little picture and say what angles are in each one. This is the 0 to 90 degrees. This is 90 to 180. You did this last week. Here's 180 to 270. This is 270 to 360.
The -80 would go the opposite direction.
-80 is gonna go backwards to 80. So -80 is gonna go back like that. So it's kind of like 0 to 90 in that direction. So we look at this. A is in quadrant 1. 54 degrees is in this region right here. And that was the A, the all. All are positive. On B, which quadrant are we in for 245? We're in quadrant 3. And which ones were positive in quadrant 3? Tangent and cotangent are positive, yes. Tangent theta, cotangent theta are greater than 0, rest are negative. Negative 80 degrees? What quadrant are we in? 4. We're in quadrant 4 for that one. What's positive in quadrant 4? Cosine and its reciprocal. Cosine theta, secant theta are greater than 0. Rest are negative. I'm gonna do a negative minus sign in this circle, like a battery sign. And 120 degrees, what quadrant are we in there? We're in quadrant 2, right? 120 is up here. That's quadrant 2. Which ones are positive there? Sine and its reciprocal, which is cosecant. You really want, like tangent goes to cotangent, you really want to say sine should go to cosine. I don't know who came up with this shit. We dealt with this problem on fucking Thursday, degrees, minutes, seconds. Why do the clock have to have hours, minutes, seconds? What is this? I forgot, we have a special guest coming, we're gonna pause this right here. Please welcome Tyler and Ainsley. They're gonna tell you a little bit about services that are available to you here.
Sorry, I didn't mean to interrupt.
No, you're all right, you're good.
Well, thank you for giving us some time. Like was mentioned, my name's Tyler, so I'm the math lab coordinator, and then today I also brought with me Ainsley, she's one of my tutors. Ainsley actually took Mr. Jones's class, so she's a great resource for you guys. If you are interested in coming by, she knows exactly what's being looked for on homeworks and things like that, hopefully. So, but we are here to represent Math Lab, so we are a free math tutoring service for you guys. It's provided on all 3 campuses. So in this campus specifically, we're located up in the library, so over in Building A. That's all close to the library. But if you haven't, it's over in Building A, you go upstairs, and then inside the library, it's like really the only room up there. But inside the library, the math lab is like the little fishbowl room kind of in the back. So you guys are welcome to just pop in at any point, just say, hey, like I need help on whatever, and then either myself or some of my tutors like Ainsley can totally help you with that.
Fishbowl room, interesting.
Yeah, that's how I describe it, because it's glass all the way over.
Okay.
I was like, the library up there is all glass, it's kind of weird when you're sitting there trying to work on stuff and you can see somebody doing a full lap around the building. But yeah, I personally am here Tuesdays and Wednesdays, but on the days I'm not here, I do have tutors or different faculty that are around. And so those bookmarks that I think you all are getting currently, those have the QR code on the back. You scan that QR code, it takes you to our website. It's got all our general tutorial stuff as well, but if you click for Math Lab on that, it'll give you all our locations, all our up-to-date hours. I try to keep that as updated as I can. So if somebody calls out, I try to make sure it's updated as well.
Depending on which one you go to, because there's a bunch of tutoring centers. Sometimes you'll see a professor there. I'm not there, but that's because I'm doing the Mesa thing on Saturdays. I can only do so many tutoring hours and 6 is good for me. But any student in there pretty much knows what they're doing. I'll vouch for Ainsley, she's currently working with me for Quick Calc 3. She was my top student in Calc 1. They hire quality students and they know what they're doing, so. If you need help and I'm not available, or you wanna it's a great spot to do homework. Cause Gerardo was with me on Saturday, he only asked a few questions, he was working home on his homework by himself for a lot. When he had a question, he asked, but other than that. You have a ready resource available for you when you need help. So it makes doing homework quicker and easier.
I'm glad on this campus, I finally convinced my boss to let me steal a couch from storage, so from all the couch up there.
Nice.
I was like, it happened while we were going upstairs, I was like, hey, just.
Nice.
So yeah, you guys are like I said, you guys are always welcome to just pop by and say, hey. I don't even really need help right now, I just want to do my work. We have laptops you guys can use if you need them for anything. I'm also available online because I know Mondays and Thursdays are the best for everybody. So if it's like a Friday, I really need help, but you don't really want to drive to Visalia, I do online appointments as well. So all that info can be found through the QR code though. You guys are always welcome to just pop up or shoot me a text or an email and say, hey, I have a quick question. And I'm more than happy to answer these. You guys have any questions for me right now?
I think they close before 5, so I think this is a daytime thing, guys.
Yeah.
But if you're here early. Some of you I know are, you have that resource available.
Awesome.
Alright, thank you.
Thank you.
See you tomorrow, Ainsley. Alright, so we had sine theta, cosecant theta, we're positive there. And rest are negative. I totally forgot I made an appointment to have them come talk to you guys. Tutoring centers really help. I guess it could, it's a great spot to do homework. Fantastic. Let's try and know something interesting. Can we figure out what quadrant something's in? If we know a couple of the signs or a couple trig values. No signs. Of a couple trig values. The trig functions. I guess I phrased that like a question, so it should have a question mark, right? Like, what if we have like tangent theta, we know tangent theta is greater than 0, and we know cosecant theta is less than 0. Can we figure out what quadrant we're in based off that?
Is it 3?
Does anyone else think it's 3? How did you get to that?
The T is positive.
So that's worth exploring. Let's see what's positive where. Both of them are positive up here, right? Both tangent and cosecant are positive up there. We know tangent was positive down here because they all strip or state CAH. Where is cosecant also positive other than that? fourth quadrant. So here T is greater than 0 and we're looking for the ones where C is less than 0. C is less than 0 over here and over here. And we're looking for the tangent greater than 0, cosecant greater than 0. Well, it looks like it is indeed quadrant 3. What about sine theta and cosecant theta? Sine theta is, let's say, positive and cosecant theta is positive. That's some of you guys. So sine theta is, let's take a look at it. Sine theta, we know is positive here, and we know it's positive here. What about cosecant theta? Where is it positive?
It's positive in 1 and 2.
It's positive. It's definitely positive here. It's also positive here, right? It's just sign flipped over, not 4. Cosine's positive in 4. Cosecant's not. So we don't really know which quadrant's in. It's quadrant 1 or 2. We're not sure, so we can't necessarily narrow down where it is based on this. I think that's a good spot to pause for now. Next up. I'm putting this down as a reminder for myself. Range of trig functions. We're almost done with 5.2. We've already done a good chunk of 5.3. So even though I didn't finish 5.2, we're still on target. Have a good day, get the fuck out. TFO. Or stick around and ask questions. Like I'm on the clock still for you guys for another 5 minutes if you want to.